Hey everyone, welcome back to Cloud Tech's Club, your place to learn DevOps, cloud, and all tech things. In the last tutorial, we understand the basics of containers, followed by installation of Docker host, where we install Docker packages and enable Docker to use on CentOS machine. In this lecture, we will discuss few important concepts like Docker components and architecture, along with Docker CLI commands. With this, let's get. So far, we have learned that Docker is a community-driven platform which created the Docker engine based on the container technology defined by OCI, the Open Container Initiative. So the Docker engine was first released in 2013 as open source, which made containers simple and accessible for the developers. Now, what makes Docker work? So Dockers use Linux features that help in creating Docker containers in the background. So the first one is the namespace, which creates the isolation layer. You can think of it as a virtual boundary around a container. It isolates the things like the PID, the process ID, network interfaces or the ports, IPC, inter-process communication, the mount points, the file system, UTS, the hostname info. So this allows each container to feel like it has its own system. Another technology it uses of C groups. C groups are also known as control groups within Linux. This is basically used for resource management, which is used to control and limit hardware usage for containers like CPU, memory, disk IO. So it ensures one container does not hog all system resources at the same time. Another one is the union file system, which provides the layered storage that helps manage file system isolation for containers, which combines multiple layers into the single view. It is supported via various technologies like overlay FS or device mapper, if you have heard about. And the last one is the container format, where all features gets combined. A container is created when namespace, control groups, which is also known as C groups, and union file system work together. These are bundled using low-level runtime like library container used by Docker in the background. Next, let's discuss the key Docker components. The first one is the Docker Daemon, which is Docker D, also known as Docker Engine, which runs in the background and manages containers, images, networks, and volumes. Another one is the Docker client, which is the command line interface, the CLI, to interact with Docker engine. You can run the commands like docker build, docker run, docker pull, docker push. So all these commands we will discuss in the upcoming lectures. Next is the Docker registry, a repository to store Docker images. For example, a Docker hub. These repositories can be public or private. You can push or pull the images from these particular registries. And the last one is the Docker objects. These includes like images as the blueprint for their containers, containers for running their instances, volume as the persistent storage for the containers, and network for communication between the containers. These objects work together to manage container lifecycle. Now let's go ahead and join the bits and pieces and try to understand the Docker architecture. How basically a container is created using the Docker components. So the first one is the Docker client, which is a command line tool which interacts with Docker engine. Now Docker client is the one which sends the request to create a container to the Docker daemon, which runs on top of the Docker host. This communication happens via Unix socket between the Docker client and the Docker host. On top of the Docker host, Docker engine is the one which handles this particular request. In order to create a container, first it performs the image check. Docker engine checks if the requested image exists locally within the Docker host. If found, it uses the image to create the container. If the image is not available locally on top of the Docker host, Docker searches remote registries like Docker Hub or the private registry. It pulls the image and stores it locally on top of the Docker host. At last, it uses that particular image to create a lightweight container. Once the container is running, it sends the response back to the Docker client through the Unix socket. Let's understand this with the help of a simple example within the lab by creating a container. We can run the command to launch the container. Docker container run Ubuntu. So what this command is going to perform here is it will spin up a container using the lightweight image of Ubuntu. Now here you can see it's looking for the image locally. So it didn't able to find the image. Now it will look for the image into the public repository or a Docker Hub registry. After finding the image, it will download and save the file locally and launch the container. It will always look for the latest image until you specify with some specific version. Let's run the next command. Docker image ls. So it will provide the list of images which exist in your Docker host or within your environment. Here you can see the image which we just downloaded. It will show you the size is 78.1 MB, and along with that the date of creation, it is 4 weeks ago, the image ID, and the tag is latest. Next, if you want to list the running and active containers within Docker host, use the command docker container. Let me correct the spelling, container ls. Okay, so it is not showing anything. Let me pause here. Can you think why it is not showing up anything here? So as I told, this will only show the running and active containers. It means the container which we just created few minutes back, it's not visible, or either it is stopped. So now the question is, where is the container? Now to get list of all containers on Docker host, whether it's active or stopped, we can see the help of the command docker container ls -a. So here -a refers to all. So in the output you can see the container ID, image name is Ubuntu, command is /bin/bash. It was created 6 minutes ago. Now the very important status, it's exited. This is 6 minutes ago, and the by default name provided by the Docker engine is elegant_habit. Now, if any container gets created and exited within few minutes, this exit can happen due to the multiple reasons you can think of. One of the reasons can be, suppose you have 5 or 4 processes running inside the container during the initial time. Once all 5 processes or jobs or tasks are completed within container, it means defined processes all completed within container and it may exit from the running state. Another reason can be if any process crashed during the creation of container, then it may lead to exit of container from the running state. Or if you are taking any lightweight image where no process is running, it may also lead to exit or stop container immediately after the running state. Now the question is how to keep container in running state. So before that, first understand there are various ways to run the containers. Let's see the options. Docker container run Ubuntu. So I have just created a container with the image Ubuntu. I can also use the command docker run Ubuntu, and I can also use the command docker container create Ubuntu. So it has given me the ID. If you will run all these 3 commands, container will be in the stopped state. Let's see by running the commands docker container ls. So it don't shows anything here. Let's run the command with -a parameter for all. So it's showing all the 4 containers which we have created so far. All are showing exited state and one is showing as a created state. Also, if you want, you can run the command docker container ps. It works similar to ls command. Now the question is how to make a container which is always in running state. So there are multiple options which are present. Previously we used to run container, we try to keep it within the sleeping mode. So container will be running at least for 60 or 100 seconds, which will be defined while creation of the container. Let's see here a quick example. Docker container run Ubuntu sleep. I will give it 100 seconds. Basically this is quite a old method where it will keep the terminal occupied for next 100 seconds. Let's open the new terminal, duplicate session. I will run the command here, docker container ps. Okay, so you can see here, let me run it again. So you can see here the container ID, the image, command sleep 100. It's created 55 seconds ago. Status is showing up state, which is 54 seconds. And here's the name of the container. Let's run it again. Let me try to keep it into the watch state. Yeah, this will be easy to understand. So every 2 seconds it will get updated. Basically, this is not really a better solution due to various reasons, like container is running only for the few seconds and terminal is occupied. Now, in order to resolve terminal occupancy state, we can use the parameter -d. So -d is basically used for the detached mode. So let's run the command here. Docker, let me correct the spelling. Docker container run -d image name and sleep 100. Okay, so it got created. Let's run the command docker container ls. So you can see the container id, image name is Ubuntu, and the command which we run is sleep 100, and it was created 8 seconds ago, and it is showing status as up 7 seconds, and the name of the container which is provided by Docker engine by default. Let's run this command in the watch mode so that it will get updated every 2 seconds. So you can see it is still showing up state. We have given the command of sleep 100. So this container will be running state for 100 seconds and don't occupy your terminal. So once 100 seconds are completed, it will not show up within the command docker container ls. We have to use the command docker container ls -a. -a is referred to all the containers. So till now container was in up mode, now it is not showing, so it means it's exited. So there is still a problem as container runs only for the 100 seconds. In case container need to keep always within the running state, we can use the parameter -it. -it is referred for intact terminal mode to keep container always within the running state, as well as it provides the container terminal as well. Let's see with a quick example. Docker container run parameter -it image name Ubuntu. Let's shoot up this command. So you can see here it has provided us a new terminal. This new terminal is for the container. Let's run the command here ls-a. So it will show all the information, the files and folders. We can also use one command here, environment. Yes, so it is showing us the host name of this particular container, home as root. In case we have to come out of this container safely without exiting it, we don't have to use exit from here. Don't use exit. We have to use the combination of control PQ to come out of the container safely without stopping it. So now you can see I am out of the container. I have used the combination of control plus PQ. Now let's run the command docker container ps. So you can see our container is in running state. It is up about a minute. So you can see the container ID 1598. Let's verify here as well. The host name 1958. Alright, Now suppose I have created these containers and forget to install the required packages and dependencies for my application within these running containers. Now if I want to move inside these containers, I have to use something called the attach command. Let's see this in action. Docker container attach and the container ID. Let's give it enter. So now I'm back inside the container, and here I can run whatever I want. And I can safely come out of it by using Control PQ option. So that's it for now. In the next lecture, we will explore more commands with Docker. So stay tuned for the latest videos. Please don't forget to like, comment and subscribe to the channel. Thank you.